Okay, so Chem 20, we're going to do the ideal gas law, and we're going to find the molar mass of butane in a lighter. So you can find this lab in your textbook, 4.3, page 179. So you're going to have to read the procedure and watch this lovely video. So here's a butane lighter, and what we're going to do is we're going to bubble the gas through the water and collect it here in the graduated cylinder. In the beginning, this is completely full of water, but as the gas gets trapped, it will displace the water. So let's show you how to do this. So what you're going to need is you're going to need a graduated cylinder completely full of water right to the brim, and a bucket with 2/3 of water. Try and have the water as close to room temperature as possible, but don't be finicky about it. And here's your lighter. So this lighter has been soaked in water, so it's not working because what we want to do is we want to measure the lighter wet. So we're going to mass the lighter when it's wet, because at the end of the lab, we're going to mass it a second time when it's wet. So I think that's good and wet. I'll shake off the excess water. Okay, and try and be consistent with how much you shake off or how much you dry it. If you want to use a paper towel in the beginning and use a paper towel in the end, just try and be consistent. So I'm going to take the mass of my lighter and of course the mass of the butane inside it. All right, so you can see we've got 14.89. I tared the scale with the weigh boat before I started, so I'm going to record that in my quantitative data table. So step 2 is to actually collect the gas in here. So what I'm going to do is I'm going to do my best to invert this graduate into the bucket of water. So I don't want to let any air in here at all. So I might have to do this more than once. Oh, I got a little bit of air. All right, so you can see I've got a tiny air bubble there, but I'm going to go with it anyway. And I'm going to put my lighter in the water, and I'm going to start to bubble through the butane. So you can see the bubbles are displacing the water. The column of gas at the top of the cylinder is growing. And I would do this for quite a while. Maybe I'm going to try and get about 100 mils. So we're going to do this until we have 100 mils. So this volume, of course, will be something we're going to use in the PV equals nRT equation. Okay, so I'm going to stop, but in the real situation, you're going to continue till you get 100 mils. So what you're going to do then is you're going to measure the amount of gas you've collected. So in this case, you can see the line 40, what is this, bottom of meniscus. I have got, so here you want to measure the meniscus. I've got 46 mils. So I've got 46 mils of gas from my lighter. So the question is, how much butane left the lighter and was trapped in the cylinder? So I'm going to remass my lighter. So I'm going to take a look here. I've tared the scale. It's at 0. I put the lighter on again, and look at that. I've lost mass. All right, so you're done. You've got all the measurements that you need in the practical lab application. Now let's look at the theory. So how do you calculate molar mass? Well, molar mass, of course, the units are grams in 1 mole. So you need some unit of gram, and you need a unit of mole. So for us, we measured a lighter before and after, and of course the gas that escaped is missing. So you're going to take the mass final from your data table minus the initial mass of the lighter from your data table divided by moles. Moles is PV over RT if you manipulate the ideal gas law. Okay, so pressure. Well, did we take any pressure measurements? No, but we are in the age of technology, and we can go onto the weather network and we can find the pressure value is here. So we're going to do that for this very day that you do the lab to make sure we have a good pressure value. So there in kPa, that's nice units for us. Where's this volume going to come from? Well, of course, this volume is from the cylinder. So whatever gas you collected is the volume you're putting here. So if you collected some milliliters, you're going to have to change that to liters, and then you can put that there. Okay, so we've got pressure, we've got volume. Of course, we've got R, it's the gas constant, 8.314. And the temperature, you can just read the temperature from a thermometer in the lab. So here we've got a 23. Okay, so then you've got temperature. Of course, the temperature is in degrees Celsius, so you need to put that into Kelvin and put it in here. So then you've got grams, and you've got moles, and you can calculate the molar mass of the butane. So what do you need to hand in for marks to get top mark? Well, what you want to do is you're going to have the problem straight out of the book on page 179. You need to make a quantitative observation table. So read your procedure and think about all the things you have to write down in that table. So they should all those things in your observation table should be enough to calculate the molar mass. Please remember to put a descriptive title and put units on all of those quantities. Okay, analysis. Show the calculation for molar mass and make sure it's communicated well. So let's see your equations, maybe end it with a sentence, show me the calculations of the molar mass. And then I need to see a percent error. Theoretical minus actual over theoretical times 100. So the actual is from the lab. That's what the A is for, right? It's the actual from the lab. The theory is from the textbook. So in this case, the textbook is the periodic table. So if you find the molar mass of butane from the periodic table, you can do this percent error calculation. Conclusion. Answer the problem. The conclusion is always in a sentence format, paragraph format. So I want to see you answer the problem. 2 sources of error. So think about them. And how can we improve those sources of error? Okay? So you've got these things for the lab write-up. And then if we're lucky, we might blow up the butane.